For those of you that were not here on Tuesday, I just wanted to review a few introductory comments. This is Environmental Politics and Law. My name is John Wargo. I'm a professor of political science as well as environmental policy in the School of Forestry and Environmental Studies, the Department of Political Science, and I have an appointment in the college for which I chair the Environmental Studies major. And this course is really designed to give you an overview of environmental law, some of its founding and key principles, but also to get you to think more broadly and deeply about our capacity to use law to shape human behavior. And I think that the cases that we'll go through will largely be historical cases, but they'll be designed in a way and presented in a way to encourage you to think about evaluating law, to think about what's worked, what has not, and why, as a way of thinking about how you might design law for the future. And the cases that we'll look at, I'm going to concentrate on today. And these are a variety that I've had a chance to work on during my career. And the relationship between law and science will be a really critical component of this course. There are no prerequisites for the course, so that you don't have to have training in chemistry or biology to do well in the course. But what you'll see is that scientific uncertainty, especially, is really important, and how different groups exploit scientific uncertainty. They choose their own data selectively to tell their own narratives about what's worth worrying about. So this course is really designed to get you to think about what's worth worrying about in a deeper way, as a way to encourage you to think about your own behavior, but also how you might encourage others to behave in a more responsible way. This is not a course in how to be an environmentalist. It's a course in how you might think about defining problems and solving problems to really help us think about the world that we're creating, a world with many billion more people in it, given our scarce resources. So today what I wanted to do was just to briefly, once again, in about 30 seconds, review the obligations of the course, which are to show up. It's important to show up. All of the slides will be posted on the class's server just after the lecture. And what I'm hoping you'll do is come to the lecture, because you'll see often just images and you won't know how to interpret those images. And via my voice, I'll be interpreting them for you. And also, the discussion sections are critical to the course, so that it's important that you go to your discussion sections. And I think that all the times have been posted. Is that correct, Laura?
It'll be up on Friday.
All the times will be up on Friday so that you can make your choices. We have 8 different sections that are set up, and we're hoping that that's sufficient for the class. There is also the obligation to either take a midterm paper or conduct a research effort that would produce a paper, roughly 10 to 12 pages in length. And I'll talk more about that. And as I lecture, I'll often pause and suggest what I think are interesting research topics that will span a whole array of different kinds of laws and problems that we'll cover. So that that will be followed at the end of the course by a final examination that also I'll provide a review session for. And I wanted to make one thing clear about this. I made an obligation to give a lecture at Elsewhere about a year ago that is up at Dartmouth next Thursday. So we will not have class next Thursday, but I will make that up by providing you with a lecture at the end of the course, an additional lecture which will review all the course material for you prior to the final exam. So let me start in. My interpretation of the failures and successes of 20th century environmental law is very much tied to how problems have been defined. And if you look back in history, you'll see that problems that have become immediately apparent, have reached the press and a wide public, have often been translated into law. So if you think about the Cuyahoga River, which used to catch fire routinely in Ohio, used to catch fire because of the petroleum products that would lie on the surface of the water, that prompted changes in the Clean Water Act to try to reduce the emissions from industrial facilities into the rivers. The Toxic Substance Control Act evolved after concern about a variety of events, as well as the Resource Conservation and Recovery Act that applies to hazardous waste sites, following the discovery that a canal that had been loaded up with toxic substances in New York State, known as Love Canal, had turned into a school site. The corporation had basically abandoned the facility, and it was turned over to the community, which built a school. And gradually this seeping, oozing toxic soup started bubbling to the surface of the playground and people's backyards and into their basements. And that prompted the passage of the Superfund law back in the 1980s. So in many respects, law follows public recognition of significant threat that is a surprise in a sense. But these laws evolved not in a systematic way. It was not as if somebody said, okay, we need air law, we need clean water law, we need toxic substance control law, we have to worry about hazardous sites. And what about all the federal land management responsibilities? How are we going to manage grazing lands, timberlands, access to minerals? How about private development? How are we going to manage new development, new subdivisions? Rather than there being some sort of a comprehensive vision about the nature of law that was specific, saying, okay, this kind of problem should be dealt with best at the federal level, as opposed to another kind of problem should be dealt with by states, and what about local governments? Which level of government has the best capacity to deal with which kind of problem? No one sat down and thought comprehensively about this. And the result is really what I think of as a fragmented patchwork quilt that's quite frayed of various statutes that are pieced together that have embedded within them different decision standards, as well as different levels of funding, and administered by a variety of different agencies. So when I talk about environmental law, you probably know that the Environmental Protection Agency has a primary responsibility to administer some of the core statutes like the Clean Air Act and the Clean Water Act. But there are many other statutes that deal with chemicals in the environment that give authority to groups like the Food and Drug Administration, the Consumer Product Safety Commission as examples, and often responsibility for one kind of a problem, and we'll see this particularly with respect to pesticides, is fractured among different agencies with responsibility to implement. So the Department of Agriculture has a responsibility to consider the benefits and cost to farmers of new pesticide regulations. EPA has the responsibility to look at toxicity data for pesticides and to judge what the risk is and to set the standards. The Food and Drug Administration has the responsibility to go out and monitor what's in the food supply so we know whether or not people are being exposed to dangerous stuff, chemical residues. So does this make sense? That absolutely does not. And then when we get to the pesticide case, I'll tell you a story about how I tried to pull data together from the Department of Agriculture on what people eat, pull data together from the Food and Drug Administration about what residues they found in those foods, pull data from the Environmental Protection Agency together in a way that made sense to try to figure out what you or an individual might be exposed to and what your risk might be. The databases were all set up in different formats, using different software. It was a nightmare, and it took about 3 years to integrate the data sets in order to answer the simple question, what are people exposed to? So the patchwork quilt that's frayed, that offers insufficient protection, is a key image that I want you to carry with you. How we define problems often will result in the effectiveness of the solution. And often the problems have been highly reductionist in their definition, and this has also been associated with their assignment to specific agencies. And we'll see that many of these problems cross many different boundaries, and the absence of thinking in a systems way or thinking ecologically lies at the core of the issue. So what are the central questions of environmental law? One is the level of government that's appropriate to the problem. Clearly, if you have air pollution blowing across state boundaries and local boundaries, if everybody sets their own, every state sets their own air pollution law, that's going to be a nightmare. Everybody has their own, if each state has their own standard. Another key question would be what branch of government should establish the law? So should it be the Congress or should it be the executive branch? So EPA has the authority to set regulations. So Congress passes a statute, sets out broad guidelines, and then the Environmental Protection Agency has the authority to set regulations that really are more refined and dependent upon scientific evidence. So you really wouldn't want Congress to get involved in the setting of highly specific regulations that really would demand an understanding of the technical details. What's our capacity to detect this chemical? What's our capacity to understand its risk? Who's most at threat? What are the costs and benefits associated with a regulation? Do we really want Congress to deal with that kind of specificity? And I think often not. Therefore, the executive branch, meaning the Environmental Protection Agency or other regulatory agencies, are often given that authority. When they're given that authority and they don't do anything about it, as has been the case for many of these problems, Congress often will call them up and hold hearings and demand them to explain why nothing has been accomplished. And we'll talk about the Safe Drinking Water Act as a great example of that, where Congress finally threw up its hands and said, EPA, you're just not doing your job, and we are going to specify which chemicals you have got to test for in drinking water, and you have got to set maximum contaminant levels for those chemicals in drinking water, and you've got to do it by date X. They did that also with the hazardous chemicals law, so that Congress does get upset. Regulations can be passed by the President via executive order. And also the judiciary plays a really critical role, so that the collection of decisions surrounding any one of these problems creates precedent for future decisions, and courts are often in a position of interpreting uncertainty in the language of statutes, but also uncertainty in the language of regulations. And they're highly individualized cases, and unfortunately the process of adjudication in the court system is not very close to the process of discovering new knowledge that we think about here within the academy. It's not about discovering truth. It's not about proving causality. It's about control of evidence to tell a story. So the courts really are looking at competing narratives of what the problem is, what the damage is, and whether or not the defendant really is responsible for adversely affecting the plaintiffs. So another key question is monitoring and surveillance, and it's very easy to pass a law that sounds great on its face, but if you look at it really carefully, what you'll find is that there's really no comprehension of how much monitoring and surveillance is required in order to really do the job, to get the job done. So monitoring and surveillance I think of as one of the primary defects of 20th century law. So we have grossly misunderstood the amount of money that it will take to really figure out what happens when you release a chemical to the environment. What happens if you blow it out of your tailpipe on your car, or it comes out of a nuclear power plant, a radionuclide goes up into the air? What happens to that? To figure that out is extremely expensive. And in society, with respect to air pollution law, chemical law, even endangered species management, understanding how many individuals of both sexes of endangered mammals exist, where they are, what their reproductive rate is, that takes intensive monitoring. So when these laws are passed, if the government does not set up a really effective and efficient monitoring and surveillance program, the whole thing is just like a waste of time. So the level of misunderstanding of this issue, I just cannot emphasize enough. Another key question is access to data. So who should have access to data? And I'll give you a good example of this. I'm working on a project now, and I'm working, it happens to do with green building standards. And I was wondering about carpet treatments and the Stainmaster carpets, as an example. Everybody's heard of Stainmaster. Other chemicals are applied to the surface of carpets to keep them from absorbing stains or to keep things from sticking to them. You might think about cookware as another example. A lot of cookware now, you don't have to put any sort of an oil into it in order to keep things from sticking in it. So the chemicals that are used to accomplish this, including to make your clothing waterproof For example, I was skiing last week, and I looked down at myself and I said, boy, you know, I thought this was just, you know, a nice waterproof shell that I was wearing. And then I started thinking, oh, you idiot, you know, you're wearing a product and you have no idea what the ingredient is. And I'm reading a report saying that everybody, almost everybody, has this chemical in their body, and it's detectable in their human tissue. I mean, so all of a sudden, now think about this history. The chemical is released into the marketplace. It gets used in nonstick pans. It gets used to be sprayed on the carpets to keep you know, red wine from absorbing to the fiber. It gets sprayed on surfaces such as clothing to keep people dry, so that the functionality has been the primary concern. Nobody asks the question, what happens to this chemical? Then down the road, somebody says, well, let's test blood, or let's test urine, or let's test body fat, or maybe even hair to figure out where this thing is going, or whether or not it's there. And they find, lo and behold, that it is there. And then to try to get the chemical out of the marketplace, which is now global, is a very difficult thing to accomplish. So access to data. I'm reading this report about this data, and one of the major corporations, DuPont, has been producing chemicals that have this effect, and they submitted a report to EPA. EPA put it up online, and I've got to show it to you. I haven't gotten it up in a PDF format yet, but I've got to show it to you because every page has the title of the topic, and then it has CBI written on it, with nothing else. CBI is the acronym for Confidential Business Information. So the information was submitted from DuPont to the Environmental Protection Agency, and the Environmental Protection Agency basically shuts down the public from understanding what that is. And it's all about how much of the chemical is produced, what the company knows about where it goes, and also what the health effects or environmental effects might be. So access to data, intellectual property rights, secrecy and confidentiality, these are all things that we really need to think about very carefully when we structure environmental law. Another key question, number 5, is should we allow preemption? Preemption is a really interesting idea that the federal government could prevent a state from adopting regulations that might be different or less restrictive than the federal standards. And the Clean Air Act is a great example of this, because the Clean Air Act does preempt states from adopting regulations that are different from the federal standards with respect to vehicle emissions, power plant emissions, mercury emissions. And the state of California, however, was exempted by Congress when that statute was passed. And why is that? Well, it's because they have some pretty severe air quality problems. There are different patches in the country where air quality is very, very poor. And one is the LA Basin. Another is the Salt Lake Basin, and Houston, Atlanta, Chicago, New York. This area is out of compliance with Clean Air Act standards quite routinely. And you might think that this geographic and climatological variability is a pretty good justification for states to have the capacity, the legal capacity, to set their own laws. So the states have, you know, far higher pollution than the national average. So that thinking about what kinds of problems are amenable to having states have more authority, as opposed to when do we want to centralize authority across all states and locate the authority with the federal government. This is a really important question. Another key question is administrative discretion versus statutory criteria. So when should Congress give the Environmental Protection Agency the administrative discretion to set standards? To judge whether or not the economic benefits are outweighing what the environmental harm might be? Should they have the authority to do that? So if you adopt a utilitarian standard that's cost-benefit balancing, or say risk-benefit balancing, then you're basically giving the agency a lot of discretion to do their technical analysis and to try to figure out how to go through that balancing act. That gives them a lot of authority. As opposed to setting statutory criteria saying the risk shall not be greater than X. Say cancer risk should not be greater than 1 in a million. Or the decision standard within the Food Quality Protection Act that the agency must find a reasonable certainty that no harm will result from any pesticide. Sounds unfortunate. So thinking about whether or not it makes sense to give an administrative agency, that kind of discretion, is very important, and it depends again on the technical nature of the problem. Another key question is risk averaging. If you have lousy data, data that is collected maybe with very small sample sizes, so that you have no understanding of demographic variability and exposure, or in the complex temporal and spatial distributional patterns of pollution, then it's like looking at the world without my glasses on, which is, all the students look the same, so that you lose any resolution, you lose the ability to identify pockets of serious problems or high risk or high exposure. And if you don't have that resolution in your data, you can't go in and protect the most vulnerable, those people that are most at risk. So if EPA does not have good monitoring and surveillance data, they get to a position statistically where they're forced to average very broadly across space, across time, and across demographic groups. And this is a very serious problem. Getting our system of environmental law to have the scientific and evidentiary foundation that allows the analysts to discriminate between what's a really clean area and what's a really dirty area. And I'll give you one example of that that we'll look at later in the term with respect to vehicle emissions. I wondered about this because EPA sets their air quality monitoring out in fields. There's one just across the Q Bridge on Interstate 95, right next to the highway. When you go across, you get to the other side of the bridge. If you're heading east on 95, you can see it set up on a little platform. So that's a fixed monitoring site where they're measuring particulate matter, they're measuring ozone, occasionally, very occasionally, they measure VOCs, so that their image of the distribution of air pollution in the nation comes from this network of fixed stations, and they've got probably 24 set up in Connecticut. Well, I wondered whether or not you would come to a very different conclusion about the quality of air and the movement of pollution, particularly vehicle emissions and the carbon particles I was talking about on Tuesday, if instead of reading your data coming from the stations, you put the monitors on kids and you followed them through their daily life. And the answer is, of course it's different. It's radically different. And I'll demonstrate in a few weeks why that is. So EPA has this image of pollution being quite uniform across the state or across a region, whereas the pollution that you inhale on a daily basis coming from secondhand cigarette smoke or firsthand cigarette smoke, coming from vehicle emissions, coming from power plant emissions, power plants in Ohio. Generally it takes about 2 weeks for particles released to the air in Europe, if they're very fine, to make it into the stratosphere and to go all the way around the world and then come back and become part of our climate. So that it's very interesting that your image of what's worth worrying about is very dependent upon this monitoring and sampling and how specific it is. Number 8 is really critical, the burden of proof and the standard of proof. Who should bear the burden of proof that a problem is really serious? Well, industry often claims that it's the public's responsibility to demonstrate that their emissions, their chemicals, their harvesting of a national forest, that is creating a problem. So if this burden lies on an impoverished community, or it lies on a group of families in a small neighborhood, they're not going to be able to mount the scientific analysis and develop the funding to mount a legal campaign to challenge industry standards. Most large corporations have groups of lawyers. They have large offices of lawyers, or they hire law firms to represent them. I've been involved in litigation for the past 2 decades and have sat across the table from 6 lawyers from a major chemical company being deposed on a number of occasions. And this was just a very small group of lawyers that were trying to pick apart, my claim that a chemical posed a specific threat to children. So most plaintiffs would not have the capacity to mount that kind of legal expertise. And don't forget this basic idea, that probably 90%, even 95% of environmental science, of health science relative to environmental quality, what sector does that go on in? It doesn't go on in the public sector. It goes on in the private sector. So that corporations that are very interested in making a profit and selling goods and services, they basically are doing their own internal risk assessments for what the effect might be on the environment or human health. And those can never see the light of day. I'll talk in the pesticide case in a few weeks about one compound. It's an organophosphate insecticide, one of the world's most heavily used. And via litigation, the group I work with forced disclosure of a database that was really quite remarkable. This company had spent $100 million on studies for one chemical to keep it in the marketplace so they could understand what its risks might be. Now, that's quite impressive. So think about challenging the quality of that evidence. Another company submitted a proposal to the Environmental Protection Agency to continue their license to use a pesticide. This happened to be an herbicide known as atrazine. Atrazine is found in the wells of about 30 million people in the Midwest right now because it's sprayed across the landscape planted with corn and soybeans. It's an endocrine disruptor. In other words, it's hormonally active. And also, it's believed to pose different kinds of threats to human health. So when this corporation decided that it wanted to submit its data to the Environmental Protection Agency, they decided to do it not electronically, but to deliver the material. And to deliver the material, it took them 2 tractor-trailer loads of boxes with the data sets and the supporting evidence, which they drove up to the docks of the Environmental Protection Agency and unloaded. So you can imagine this regulatory office of EPA looking at this huge sea of boxes that they would have to analyze. That's a very interesting strategy. So what would that do? Well, it basically would put a regulatory effort that might be chugging down the road at a good pace, and it would put it in the deep freeze. It would slow it down to the point where, oh my gosh, this agency has to look at 1,000 chemicals. This is one chemical, and we've got to go through all those data sets, and we're going to have to understand whether or not that evidence really is supportable, credible, replicable. Oh, that's going to slow things down. 1 out of 1,000 chemicals. So the burden of proof, the standard of proof, is a really critical issue. So for civil actions, you need to remember that the plaintiff needs to demonstrate that damage occurred not beyond a reasonable doubt, but by the standard of preponderance of the evidence. In other words, it's more likely than not that the defendant caused the damage. Think about that with respect to the standard of proof required if you wanted to submit a paper to Science Magazine. Well, you know, you'd be asked questions about, okay, what's your confidence interval? Do you have 95% confidence in the causal relationship that you're hypothesizing? Or is it 99% confidence? So that the standard of proof that is applied before a decision is made is a critical issue, and this can be adjusted if you're designing law. Also, national sovereignty to regulate foreign hazards. There are a variety of international standards set up to prevent the export of hazardous waste. So there's quite a controversy brewing right now about electronic waste being transmitted particularly to Asian nations, which are trying to recycle the precious metals out of computer equipment, old cell phones, and even though there may be only 75 cents per cell phone in terms of the value of those metals, there are some 36 different metals that can be extracted from electronic equipment. And if they're thrown away or if they're burned, the material will go up into the atmosphere or it will make its way down into the soil and the groundwater. And also the people that are doing this, the people that are burning the plastic off of the electronic components and the metals, they are often exposed at a high level. So that's a very interesting problem. How could we regulate international trade? Well, this issue of national sovereignty is very important. Does one nation want another nation telling it what it can and cannot import? Does it want to demand that that nation adopt some sort of a universal standard? And the answer is clearly no. And finally, what criteria would we use to choose among the possible legal strategies that are there? So I'm going to skip really quickly now to a variety of different cases. And I'd like you to imagine a society with no environmental law. And by the way, that was the United States back in 1950 when we had no Clean Air Act, no Clean Water Act. And how would you design law in order to assure a healthy, productive, and sustainable future? That is a central question that I hope you can address by the end of the course. Now, imagine a society in the year 2010, as we sit here, where our law is fractured by problem and by media. So by media, I mean air, water, food, or by problem type, hazardous wastes or hazardous sites or the pesticide problem. It's fractured by level of government. There's very little surveillance. It tends to evolve at a snail's pace. And a little anecdote there, in a variety of decisions to regulate or license an individual chemical or a new product, it often will take EPA up to a decade or 15 years to go through a review to determine whether or not that chemical is safe, whether or not it poses excessive risk, or what the economic benefit is if it's being reviewed under a balancing and cost standard. So that, now imagine this, out of the 80,000 chemicals that are out there in international commerce, if it takes EPA 15 years to review one chemical, what does that tell you about what their capacity is to manage your exposure to dangerous things? It tells you it's exceptionally limited. Our system of law also provides a false sense of security, because most of us believe that the little statements on the back of different products, such as an herbicide in the hardware store that says this is EPA's license, that's almost a certification of safety in most people's minds. Many people think it wouldn't be in the marketplace if it was dangerous. People have reviewed this, right? Well, you know, by the time you're finished with this course, you will be thinking quite a lot about that problem. So environmental law is also highly specialized in the sciences, and as I just said, about 95% of environmental science goes on in the private sector, and what that means is that they have a leg up, they have a competitive advantage in controlling the narrative about the nature of the danger. So that thinking about how to set up an institution that really would produce science that would be publicly available, that would be transparent, it would be open, the data would be out there so you or I could review it. I mean, that's a big obligation. It's also highly politicized in its implementation. There are all sorts of stories about regulators inside the Food and Drug Administration, Occupational Safety and Health Administration, and the Environmental Protection Agency, and how they move at fairly high levels from the agency, Assistant Administrator for Toxic Substances in EPA, going to work for Monsanto. They'll go to work for Monsanto during periods of liberal administration, and then they'll come back into the administration during periods of conservative administrations. So that there's this revolving door idea among top regulators that's extremely difficult to regulate. Also, our system of law is very poorly supported by the nonprofit community. You may think that there's a large network of nonprofits out there that are playing the watchdog role, but you're wrong. In fact, in the area of the Safe Drinking Water Act, there is no nonprofit in Washington, D.C. that has taken the Safe Drinking Water Act under its purview, saying this is our specialty. You can always count on them to be there to try to judge the reasonableness of a proposed regulation. Generally, in the system of environmental law that we've got, is utilitarian. It's balancing of costs and benefits, or risks, or the estimate of damages and what the economic benefits might be. And inherent in that decision standard is this problem. You've got costs that are pretty easy to quantify. And if you've got a firm that's making a product, they're going to tell you with pretty good accuracy their opinion about what they would lose if you took that right away from them to produce that product. Now, by contrast, if you think about
The damage side of the equation, or the risk side of the equation, that's a projection out into the future. That's a probabilistic estimate of what might happen into the future. And the global warming transformation in thinking that we've seen over the past decade has really been quite remarkable, because people are thinking now out over a long time horizon in ways that they never had before. You know, what is the climate going to be like, and what's it going to do to our ecosystems and to our shorelines and to our health 100 years down the road? There are very few people that think out in that long term. So how do you project damages out over long periods of time? Well, you rely on very complex computer models to do that. So that you have to have faith in those who are doing the projection and the quality of the analysis. So that this problem can be kind of capsulized in the idea that costs are often relatively well known, and they can be projected with relative precision over the short term compared to the harms, the environmental and health harms, that are highly uncertain, and they're often projected way out into the future with a really fuzzy image of how they're going to fall out differently on different groups. Also, our system of law, environmental law, has been trivialized, I think, by the concerns that we have over international security and terrorism. Basically, nobody was talking about environmental law for several years. Between 2001, following the attack on the trade centers, and 2004, 2005, environmental law came back to life. But even when the public is asked, you know, what do you care about most in terms of problems that the United States faces, you will see issues such as the economy regularly being first on that list. You'll see issues of national security being in the top 2 or 3. But people are thinking in a much about a very different collection of problems rather than environmental concern. We'll be talking about the importance of public perception of the environment compared to these other social objectives in the future. One other point I wanted to make is that the estimates today are that the system that we have in place now costs industry about $300 to $400 billion per year in the United States alone, only in compliance costs. That's pretty remarkable. EPA and other groups have reviewed this estimate along with the Government Accountability Office. That's a very large investment. So put the pieces together here of what I've just told you. I've told you that we have this system of law that is not working very well for a whole variety of reasons. Now I'm telling you that this is costing society an enormous amount of money. Well, does that make sense? We'll come back to that issue during the term. Now I'm going to spend about 10 minutes just quickly reviewing some of the cases that we'll go through that will demonstrate some of these key principles. 1954 was a turning point for environmentalism in the nation and in the world, because it basically taught people to think at a global scale about nature and about the environment for the very first time. And it's the result of this explosion on the Bikini Atoll in the Marshall Islands that punched up radioactive material into the stratosphere. And at the time they thought that, well, we had to worry about where it would go, how it would be distributed within a couple hundred miles. And a variety of mistakes were made, including exposing people working for the military. This group of people was sitting in these lawn chairs in their shorts and their caps on. They had ski goggles on, you know, with the dark lenses, thinking, well, that would be safe enough. There are many, many stories about workers being exposed beyond what normally we would think of as being a safe level today. So what you don't know can hurt you. And the more you ask about chemical movement, the more we recognize that chemicals actually persist longer than we thought they would. They often move further in ways that were non-intuitive through ecosystems, marine food chains. They may get deposited in the landscape in different ways. We'll see next week when we take this story apart that one of the major surprises was that this material got into global circulation, so that everybody in the world was exposed to radionuclides, strontium-90, iodine-131, cesium-137. And your parents are all walking around today with those byproducts that often have half-lives of thousands of years. So that these are really important lessons. The Atomic Energy Commission figured this out by 1955, 1956. They figured out that these radionuclides wouldn't just kind of go away, and that's been the perception of most people about chemicals released to the environment. They just go away. Well, many of them don't go away, particularly radionuclides. And they move around the world. They tend to settle down. The heavier particles will settle down when it's dry. The finer particles tend to aggregate, and then when a rain cloud intersects with the dust cloud, as they settle down into lower elements of the atmosphere, that's when they rain down into the earth. And that creates a patchy pattern of contamination. It's a patchy pattern, but we can figure out what the deposition rates were 50 years ago today just by taking soil samples. It's very interesting. So that you can back calculate the half-life of cesium-137 or strontium-90. And you see that it actually plays out, excuse me, in a very patchy way. That is dependent upon this intersection between the dust cloud and the rain clouds. So the number one failure that we'll see as we go through this case is a failure of systems thinking, a failure to think ecologically. But the Atomic Energy Commission was clearly thinking ecologically back in 1955. But then we've been waking up over the past 50, 60 years without really paying much attention to this story. So that we'll see as the milk was tested and the ground soil contamination levels of strontium-90 were tested between the period of 54 and 1958, when more atomic bombs were exploded than during any other period in human history. You see this correlation, this rise in levels in the soil and levels in the milk. And then you see the levels in the human diet going up during the same period of time, and the levels in human bone. They didn't know that. They didn't know that at the time they designed the bombs. So that they didn't know that strontium-90 would compete with calcium to be fixed within bone in the human body. But the Atomic Energy Commission created this clandestine operation where they collected dead bodies from 15,000 people around the world. And they sent them to labs in Chicago and to Lamont Laboratory and to Columbia University, where they were tested. And every bone they tested found strontium-90 in it, and it really woke them up. You can find this story only because this documentation that was formally classified for until the mid to late 1990s is now available in the declassified documents database. It's really a fascinating story. So these people were sitting around in the Atomic Energy Commission's headquarters actually saying, well, you know, what is the law on body snatching? They use that phrase, body snatching. Where are we going to get cadavers? Do we really have to ask relatives about this? Well, what about homeless people? So the Atomic Energy Commission was collecting bones from around the world, and they were able to build this map of the deposition rate of strontium-90 by looking at bones that came from Argentina, bones that came from South Africa. I can just imagine what their faces looked like when they saw the levels that were spanning all latitudes and basically all nations in the world. Well, this story gets repeated. It gets repeated chemical by chemical as EPA begins to come to life in the 1970s and 80s, begins to wake up, in this case to polybromated diphenyl ethers that are these flame retardants that we now all walk around with. And it's a common story that we first find the chemicals in wildlife. Why? Because they're easy to test. People generally don't like to give bone samples so that their bones can be tested for strontium-90. By the way, there's an interesting kind of way to figure out what's in your bone by testing teeth. So by testing the deciduous teeth of young kids, the Atomic Energy Commission figured this out, and they were actually going around from dentist to dentist collecting teeth from people, thinking, well, you know, why were we crazy enough to have to collect bones from dead people when we could have just collected teeth? So you find this pattern of recognition first in wildlife, then they say, oh, well, you know, how did it get into the wildlife? And then gradually somebody said, boy, if it's in the wildlife, it might be in humans too. And gradually people started testing breast milk. Breast milk became the tissue of choice in order to understand whether or not chemicals were being transmitted transgenerationally. And it also it's easy to collect. It is relatively inexpensive to store. And here's a good example of DDT found in different nations around the world in breast milk in the 1970s. So human tissue testing became really an important way to figure out what people were exposed to. And if you know that you find it in somebody's body, then you have this kind of interesting problem. Well, how do I figure out where I encountered it? How was I exposed? Did I breathe it? Did I eat it in the food? Did it come in the drinking water? So these are all questions that EPA has faced on numerous occasions. This is the island of Vieques that we'll spend a lecture on or two in a few weeks, where I've worked for a couple of years. And I've worked on hazardous defense sites and the process of their restoration for sites in Massachusetts, sites in California, as well as sites in Puerto Rico. And this is a fascinating story that led me to understand how chemicals move through the food chain. And this is a bombing run. 200 million pounds of bombs were dropped on this little island over the period between 1940 and 2003. So I wondered, where did the chemicals in those bombs go? So I took students, some from this class, down, and we dove in this bay. We found an old destroyer. We found 2,000-pound bombs that were as long as this stage and about that wide, lying underwater, rusting out, leaking. We found mounds of artillery shells. I remember one case where I was, my goggles had fogged up, and I came to the surface and looked around and looked and saw there was a tank on a hill that was only about 20 meters from where I was. And then I cleared my goggles and I looked down, and I was within about 2 feet standing on a pile of artillery shells. And I hadn't really put two and two together, but destroyers had sat offshore and for 30, 40 years were lobbing these artillery shells at the tank on the hill for target practice. And a bunch of them had missed and piled up in the same place. So they're still sitting there. I mean, I could take you there now. We could still see the 2,000-pound bombs. So the Base Closure and Reclamation Act that was established, it's closing down a bunch of these bases, has led the Army, the Air Force, the Navy to basically close bases, walk away, and clean up according to standards that they believe are safe. So this will be a story about standard setting that turns into a story about chemicals moving in the marine food chain. You've heard about mercury in tuna. You've probably heard about mercury in shark and large predatory fish, but you probably haven't heard about mercury in the array of tropical fish that exist in the Caribbean seas. Well, that's because they haven't been studied. People tend to look at the chemicals in the larger fish. They tend to avoid the study of this set of tropical fish because these don't comprise a large proportion of the U.S. average diet. Or other high-income nations that would fund this kind of research would not comprise their diet. So the problem I face in Puerto Rico is, wow, I know that these people eat a lot of these fish, and there are probably 24 that they eat on a routine basis. What happens to TNT, HDX, which are explosives? What happens to cadmium and mercury and lead and aluminum and copper and a variety of other chemicals that are components of munitions? How do they build up in fish, and is this population more exposed than others? So that island communities, whether it's the Marshall Islanders, the Seychelles Islanders, the Akenzi, that have these diets that are very rich in fish, they can be more exposed than others. So I'm going to jump ahead here because I'm running out of time, and I'll come back to these and get to the final slide. Oh, I see how much fun we're going to have. I want to leave you today with one image. I was up in the Wasatch last week. I spent 8 days, 8 days in heaven, so to speak. If any of you have not been to the Wasatch, I encourage you to go there. This is just east of Salt Lake City, about 10,000 feet in height. And standing there, looking out at these magnificent mountains, I suddenly realized, given what I've told you today, chemical movement through the atmosphere, through the environment, I suddenly realized that the idea of wildness, the idea of purity, the idea of environmental quality that most people have and most people value, it's really being challenged by the way we're using and abusing chemicals. So that the failure of law to effectively control these chemicals, to rain down in the snows and the Wasatch, to get into the bodies of different species of wildlife, into the plants and the animals, or to humans that are drinking the water, the failure to control that is challenging our very sense of what wildness is, of what purity is, of what nature is. So I'm going to close there and leave you with a sense of challenge that we need to think about a different system. We need to think about a different way for law to work that could prevent this from continuing through future generations. Okay, that's it for today. Thank you.